Look at our homework quiz for Chapter 8 on inferences. I think we have about 9 questions, 0 of 9 answered. So let's go through this. So these will be confidence intervals either around a mean that we obtain from a sample or a proportion, which is like a binary probability proportion that is true or false, doing something or not doing something. Okay, so for question 1, we start off with this question, which is asking us to build a 99% confidence interval. And we know we're dealing with a proportion of students, so the percent of students who do something, that take notes. They took a random sample, so we've got the sample size here. Which of the following is the correct interpretation of the interval? This. So now notice this P here, this is the proportion for the population. If it were for the sample, they use P hat. So they call this P hat is for the sample. So we know this interval is talking about the population. Okay, and we have a 99% confidence. What this is saying that for the population of students all in the world, in the country, wherever it is, whatever the population is, that between 12 to 31% take notes. We're 99% confidence that that is happening. Remember, confidence intervals are not about probability. They're about sort of being able to predict what actually is happening in a population. Okay, so let's read through each one of these and say why it is or not. 99% confidence, the proportion of all students who takes notes is between 12 and 31%. And that's exactly what we said, the proportion of all students. I would say that's going to be correct. There is a 99% chance. Let's stop right there. The word chance deals with probability. Remember, confidence intervals do not deal with probability. Okay, you can read the rest, but it doesn't matter. There is a 99% chance. Boom, that's got to be wrong. Confidence intervals are not about probability. And then again, this one is also dealing with the sample. This interval is dealing with the population. So another reason this one's wrong. With 99% confidence, sounding good, a randomly selected student. No. If you randomly select a student, this is now turning it into a probability, right? No, that's not right. Then the proportion of all students who take notes is between 12 and 31%, 0.12. Sounds right 99% of the time. Again, this is kind of getting at a probability statement that it happens. It's probably 99% probability it happens. But remember, confidence intervals are not about probability. So the only correct one is there. And let's submit this. And we were correct. Get rid of all of that. Okay, so kind of understanding what a confidence interval means. It refers back to the population. And we have a confidence. It's not a probability. Okay, let's keep moving forward. Question 2. Out of 600 people sampled, 390 had kids. So the rest didn't have kids, right? So this is setting us up. It's some kind of a proportion. Based on this, construct a 90% confidence interval for the true population proportion. So they're telling us right here. And they want the actual confidence interval. Okay, so we come over to our NumWorks calculator. We go down to inference. And we got to back up a little. We're going to input statistics. Wait a minute. Where are we? We're going. Sorry, I may have went to the wrong. We're way in the wrong place. We've got to go to a proportion. We're doing a proportion, not a mean. True population proportion. Okay, so we're doing a proportion. Our number of X is from this sample is 390. The population size is 600. And the confidence interval is 90%, 0.9. So our p hat for the sample is 0.65. We've got all our critical values and then our margin of error here. And the way we read this margin of error, it's about a 3% plus or minus. So what we're going to see in the next window will be about 65% plus or minus 3%, 3.2%. But we just click on the next and it's going to give it to us, right? So 61.7, they want give your answers to 3 decimal places. They're not as percentages, so they're as decimals. 0.61, we'll round the 7 to an 8. 0.618. You could put the 0 in front if you want. I'll do that. And then the second part is 0.682 to 3 decimal places. 0.682. And then we can see that our answer is correct. Okay, so that's how we do a population proportion confidence interval. In a survey of 32 people, 32 people were asked how much they spent on their child's birthday gift. So we can kind of see, I won't read all of it, but we've got a mean in here. So it's not a proportion, we're dealing with a mean. We've got a standard deviation. Key part, is this standard deviation from a sample or is it from the population? Well, they're taking this, they're saying it's a result of the survey. So this is a sample standard deviation. Construct a confidence interval of 95%, an 95% confidence level. And notice this time they want the mean here. It's going to be plus or minus, so they don't actually want the interval. Now, the thing is do we do a z or do we do a t? The thing is, it's roughly bell-shaped. That's good. But the key part is the standard deviation that we have is a sample standard deviation. So let's back this up. Actually, I'm going to just click on the menu button, go all the way back. We're going to go to inference. Oh, that didn't help. We'll back up to this level, intervals. We've got a mean, so we're doing one mean. And I'm going to say it's a t interval, not a z. And what you'll see is if you went to z, there when you go to the input, you need to put in the population standard deviation. We don't have that. Okay, so we'll back up. T interval. Got to choose the right interval. We'll input our statistics. We can put in the mean. It's a sample mean, 41. And we'll put OK. Sample standard deviation is $9. The sample size was 32. And the confidence interval that's being requested is 0.95. Go to next. We've got all this information, and what we're going to see in our next window, we're going to use this bottom part here, 41 plus or minus 3.2 to 1 decimal place. Okay, so our confidence interval is that the mean is 41, and again that's always going to come from this sample as it is, plus or minus 3.2, and that's what the confidence interval. So that's how they want us to state it there, and we're all good. Now, had we used a z, I imagine we would have been off. But give it a try. All right. Question 4. SAT scores are distributed with a mean of 1,500 and a standard deviation of 3. You're interested in estimating the average SAT score for first-year students at your college. If you'd like to limit the margin of error of your 95% confidence interval to 25 points, so that's the margin of error, how many students should you sample? Now, what you're going to have to remember is that we have this formula, or at least have it written down somewhere, that we can calculate the number that we need in a sample by this formula where we take z critical times the standard deviation of the population divided by the margin of error that we're trying to achieve, and then we square this. Okay. So we have the margin of error. That's what this is. We want the margin of error to be no more than 25. So we'll put in 25 for E. No, I put 25E. Standard deviation, and this comes from a population, so that's a population standard deviation, so that is our sigma. Z critical, we'd have to look that up. If you remember, 95% confidence interval for the Z's is always going to be 1.96. Okay, since we've got to go to our calculator anyway, I'm going to say this is a 95% confidence interval. This is on a T though, so that's not going to help us. If we back up and go to Z interval, we can always use our calculator to look this up if we didn't have it. The mean doesn't matter, the standard deviation doesn't matter, sample size doesn't even matter, it's just the confidence set. So if we've got a confidence level of 95, when we go to the next screen, we will get our critical value here. Z critical value is 1.96, rounded, right? So you can look it up this way or just have it down somewhere. So anyway, in the end, we can calculate the number we need as 1.96 times 300 divided by 25. And then in the end, we're going to square it. Okay. Go back to the main menu, up to calculate, and we just enter this in. I'm just going to kind of enter it all in. 1.96 times 300. Oops. 300 divided by 25, arrow over, put our other parentheses, and we're going to square that. 553.1. So we need at least that many, so we're going to get 554. You always just go to the next highest level because you want your sample to be big enough. 553 would be just a little small, so we're going to go to 554. Okay, and I don't want to mess all this up, so we'll take a look. 554, exactly what it is. Okay, now we're going to go through these questions here, and these are all about, it's a three-part question, which confidence interval has a larger margin of error, a larger plus or minus. So notice in the first one, they're both 90% confidence intervals. One has a sample of 45, the other has a sample of 55. Now remember, the sample size in the calculation, it's a division. We divide by this. So the larger the sample, you're dividing by a larger number, which gives you a smaller margin of error. The way to think of it is you're going to have, the larger your sample size, you're going to have a smaller confidence interval, okay? Because you're going to be able to be more accurate. So it's this one, the smaller sample size. Actually, we have a larger confidence interval, and sort of that's the unknown. Here, there is asking a slightly different question. The sample size is the same, but then if your confidence interval 90 or 92, which one's going to be wider? This one's maybe a little easier to see with the same sample size. 92% confidence interval is going to be wider, right? Because we're stretching out. We have an extra 2% of confidence in here. So everything else being equal, 92% confidence interval is going to be wider. And then finally, this last one, confidence intervals are the same, sample size is the same, but do we use the standard deviation from the population or the sample? And just thinking through this, a sample is going to have more variation. It's not as accurate as using the parameters, using information from the population. So there's going to be greater error with a sample standard deviation. Okay, and again, here we can see, yes, it's the sample size. It's the one we chose. This one, 92, is the one we chose. And this one, using sample size, that's the one we chose. And just to be sure, when you submit your question, you'll see we've got all green. Okay. Question number 6. For a confidence level of 96%, find the critical value z value. So we go back to our menu. We can go to inference. We'd also do it with the distribution, but I like doing it here. We just need to make sure we're doing a z interval. And then when we put in our statistics, the critical value is only affected by the confidence level. So if we put in a 0.96 here, we leave all the defaults and we're going to be fine. We get our critical value of 2.053. 2.054. I'll round it. I'll go to 3 decimal places. Right. Cool. For a confidence level of 98% with a sample size of 29, find the critical t-value. Now remember, with t-values, sample size does make a difference. So when we come back to find the t-value, input our statistics, we just accept the default for the mean and standard deviation, because those don't incorporate into the critical values, but the sample size does. So we put in our 29, and our confidence level is 0.98. And we go to the next, we've got our critical t-value, 2.467. We submit that one. We're good. Okay. Suppose you compute a confidence interval with a sample size of 42. What will happen to the confidence interval as sample size is increased to 53? Well, remember, it's going to get smaller. It's going to get sort of more accurate the larger the sample size. So it will narrow. That's the way to think of it. Larger sample size, narrower confidence interval. If we went with a smaller sample size, then it would have widened. Different sample sizes will make a difference. Okay. Our last question here. You measure 32 backpack weights and find that they have a mean weight of 33 ounces. Assume this is the population standard deviation is 5.2 ounces. Based on this, construct a 95% confidence interval. Since we have a population standard deviation, we have to use the z interval. Okay, we have a mean, we have a standard deviation from the population. Again, if you went with the t-interval, you come here, what is it asking? It's asking for the sample standard deviation, but you've got to look, we've got the population. Okay, so make sure you're using the right interval, z interval. We input our statistics. 33 ounces is the mean. 5.2 ounces is the population standard deviation. Sample size was 32. And the confidence level that's being requested is 95, which is the default. So we can just go on to our next. They want the actual interval here, or the mean plus or minus. So what we do is we go to the next step. This is what they want the confidence interval expressed here as being 33 plus or minus 18. Let's say 2 decimal places, 18.02. Okay, and that we just get from right down here at the bottom. Sometimes it will actually ask for the interval, so we would put these numbers that are given here. 14.98 and 51.01, but in this case, they want the plus or minus. Submit it. Oops, what did we do wrong? 18.0. Let's see. What did I do wrong? Maybe I entered something in wrong. Oh, 5.2 ounces. I put 52 ounces. Okay. I should have thought it through. Okay. I don't think it's going to let me do it, but we'll see. Sometimes that's the problem. I thought, I definitely entered everything correctly, but I forgot a decimal point. So it's actually going to be 33 plus or minus 1.0. 1.8. It won't let me change it now, but being the teacher, I can see that that's 33 plus or minus 1.8. Okay, that's what I should have had. But it was because I entered the standard deviation incorrectly. So catch those things. And then I could believe that I would make that kind of an error, so I just kept pushing forward. So anyway, take your time. Make sure you've got it all there. Hopefully this has been helpful. Go through the homework quiz, and then you should be pretty much ready to deal with the rest of the questions in the homework. Thanks.